Okay, so we are looking at number 8 in still the same section, 2.1. Number 8 asks to fill in the blank with this notation or this notation. We have 2, then we have this blank, that's what we're filling in, and we have the set 2, 6, 8, 9. So remember that this notation means is an element of the set. This notation means is not an element of the set. This is our set because we have braces around it, and we see that 2 is right in there. So we would use this notation because 2 is an element of the set. Anything inside, right? These braces, once again, mean set. Whatever is inside is an element. All right, so that is number 8. Number 9, same thing. We either use this notation or that notation to make it true. So now we have 8. Here's our blank. And this is our, this is our set. So we take a look here. Does not look like 8 is in there, but if we simplify 12 minus 4, that actually gives us 8. So now that is our set. We can see that 8 is in there. So once again, we use this notation, right? Because 8 is an element of the specific given set. So that's number 9. Number 10, still doing the same thing. Well, number 10 asks us, is this true or false? All right, and it looks something like this. All right. So, very interesting here, right? Because here, the fact that we have braces means this is a set. Here we have braces means that's the set. But take a look, the inside, so the elements are also sets, right? So this reads the first set, this set is an element of the second set, right? And that is true because everything in here are sets, right? So nice true statement there. Number 11. Number 11 here tells us that this set C has elements 11, 17, and 19. We want to know if this is true or false. So it's just being able to read this. This reads 11 is not an element of set C. We see that this is false because set C has 11 in it. Right? So a false statement there. Okay. Number 12, right, gives us this set A with these specific numbers. Gives us set C with these specific numbers. Question here is every element of C is also an element of A. Right, and is this true or false? Right, so is every element of C also an element of A? Right, so we take a look at C that has 10, 16, 18. We take a look at A that has 8, 10, 12, 14, 16, and 18. We see that 10 is in there. 16 is in C. It's also in there. 18 is in C. It's also in there. So this would be true. That would be true there. All right. What about the other way around? 13. A has 4, 6, 8, 10, 12, and 14. B has 4, 6, 12, and 14. Now, what if we say that every element of A is also an element of B? All right, so now we're going to look at everything in A. Are all of these in B? That's the question. Well, I'm just going to look at 8. It's not in here. So then this would be false because I was able to find at least one that's in A that's not in B. So some nice examples finishing up 2.1.